was gonna clean up my desk before you guys came, but I'm a big believer in everything in its place and everything placed to its thing, and it's so hard to get that arranged back that way after you go home. Yeah.
I can use that.
Scheduling speakers is always a interesting exercise. When we started doing trade shows in 1991, typically at a convention, they would have one or two tracks, 2 sessions in the morning and 3 in the afternoon for 2 days. So 10 sessions, or in a big convention, 20 sessions. We started our BBSCon, which became ISPCon. At one point, we were doing sessions in 23 separate rooms simultaneously over the course of 3.5 days, and would often have 250 speakers. And it changed the way they did trade shows, and today all trade shows have a lot of sessions. And the reason was that they would have some speakers, and some guys volunteer rather readily to speak at a convention because it's a good opportunity for them to sell stuff, which is okay as long as you bring some information. Some of them just basically came and sold stuff, and it would enrage the crowd. We accidentally learned that if you have like 8 sessions going on, everybody's kind of agonizing between 2. And that if they get in a room with a guy that's selling a bunch of stuff and not really bringing any information, they would bolt for the door in the first 7 minutes to go to the other one that they decided not to go to in favor of this one. But guess who's not on the hook? The convention didn't get bad speakers, I just picked the wrong one. And so we were out from under on the speaker selection, and the attendee simply assumed they picked the wrong room. And so that was kind of it. EVCON, of course, has been a smaller, more controlled thing. One of the speakers we had the first year was a guy from Helwig Carbon Brushes, doing a section about brushes. We were very much about DC motors in those days, but even then, my emotional attachment to brush issues was a little vague. And what would you say about a brush in a DC motor? It's a piece of carbon with a wire. And so I kind of slipped him in on Saturday morning when everybody'd be asleep. Most of them would be asleep at the hotel, some of them would be at the convention, but still asleep. And I showed up, got up, threw him under the bus, and walked off the stage. Man, he gave the best presentation of the EVCON. And he actually made brushes kind of interesting, even to me. In fact, later I think he had some minimum number, and I ordered a bunch of them, and I think I've still got $4,000 worth of brushes. But he gives a great presentation, and he's been talking to me in the last year or two about brushes for AC motors. And that may strike you as an odd topic. It strikes me as an odd topic. So I can't wait to hear what he has to say about it. Would you all give a warm welcome to Tom Brunka of Helwig Brushes. I'm going to give you my microphone. Okay?
Thank you. Hopefully I can do this without feedback, right? Hey, does that work?
Yep.
As long as I keep my back to the speaker?
Yeah. You could do to crank it up a bit.
I think it's up already.
Really, as far as it goes?
Well, I don't know. I think it was. Just to hang on.
Speaker? Volume? More?
Yeah, I don't know if we want to go that far.
Sure we do. Go on, do it.
Oh, it's, I can hear it
Push it.
starting already.
Think someone else to.
Can you put the mic higher? Maybe that will help you for overall volume.
Closer to your mouth, where the sound is coming from. Yes.
Yeah. Maybe.
Here we go.
Oh, that's much better.
How's that?
Yeah.
Okay. Stay away from the speaker. Okay, let me get some papers organized here and get away from the speaker. Okay. So here's a picture of our standard shaft grounding brush and brush hole. Okay. This is a picture of our standard shaft grounding brush and brush holder, constant force spring, standard assembly. Why do we need to ground the motor shaft? There's voltage and current induced into the shaft of the motor, and there's many reasons for that. These are shown here, and it's going to do damage if you don't take care of this. The motors that are most susceptible are these motors listed in this slide. I can simplify this and say it's going to be any motor that's driven by pulse width modulation. That includes all three-phase motors and DC motors. It's pulse width modulation from fast switching semiconductors such as IGBTs or MOSFETs, and that will induce shaft currents. Here's some of the electrical reasons for that, going into common mode voltage, common mode current, and some of the methods that this is generated. The majority of this induced shaft current will occur due to capacitive coupling within the motor. So the higher the frequency on your carrier frequency of your VFD, your variable frequency drive, the higher that frequency is, the more voltage and current you're going to induce into the shaft. What happens when you induce this current into the shaft? It's always seeking a complete circle, a complete path, and it will jump through the bearings, through the grease. The grease in the bearing has got an insulative effect, and this will fire almost like a spark plug. When the voltage in the shaft builds up to high enough value to jump through the insulating grease, it will jump through the grease, essentially fire this spark plug, which is really a bearing, and cause pitting or fluting in the bearing. And here are some pictures of that effect. And this will cause premature bearing failure and rumbling and all sorts of noise from that. There are many options to prevent this bearing problem, and these options are listed here. The best value, most reliable method to prevent this is going to be the bottom grounding brush that we make. And here's a picture of our standard kit installed on the face of a small motor. And there's many, and other motors too. There's many different methods for installing this. We're going to make it as easy as possible to install it, and you can get this installed and running pretty quickly and easily. When you have large motors or large vibration, you're going to need to install more than one of these brushes, and you don't want to install them in the same vibration plane. So we recommend that you mount the two grounding brushes on 90 to 120 degree radius to make certain that you maintain contact to get the lowest possible shaft voltage that you can. Here's an example of one of our small shaft grounding brushes and brush holders that we designed specifically for an OEM so that they could install it as standard equipment in their motor. And it also has the constant force spring and the silver graphite brush that we normally use. And this is the motor it's installed in and where and how it's installed. So as an OEM, they've decided to put that into their premium motors as standard equipment.
How serviceable is that internal like that? Is there a hole to replace it, or?
No,
Okay.
no. But wear rates are very low. We've done testing on that recently, and we found wear rates are on average 1/1000th of an inch in 6 weeks of continuous running.
Is there a wear indicator?
No, not on this one.
Yeah, this was Patrick probably. What are you grounding it to?
You ground it to a ground point. Now, all VFD manufacturers will tell you that the building ground, the VFD ground, and the motor ground all have to be the same point. And the brush is usually then grounded to the motor frame, which is also on this same point. So you're providing a parallel path to the bearing, and the parallel path is of much lower resistance than the bearing is. So it will hold voltages very low. And here's that slide. Thank you for the segue. So the upper portion of this is the shaft without any bearing protection whatsoever. It's just the motor running off a VFD, and that's the voltage you're going to get. And then the bottom slide is after we put our shaft grounding brush on there, and you'll notice that the scale on the scope is set the same in both cases, so it shows the magnitude of reduction, which is what we're trying for. And here's some examples of some of the recent test stands we've built in the last year. And this testing on these stands are pretty much done now, but I'm still working on this project, and I'll be continuing for another 2 to 4 weeks in order to gather all the data that I'm trying to get. Here's another example. This is one that we have had installed since before I started at Helwig, so it'll be over 10 years. And you can see by the inset picture on the lower right that the brush is roughly half worn. So that's doing pretty well. Of course, this is in a lab, so it's kind of an ideal condition. But we do have copper dust and carbon dust in that lab, but we are controlled in temperature and humidity, so that helps to prolong its life. And here's another example. This one has been in service in our lab also, but not as long, roughly 3 years. And you can see again by the inset picture, it's barely worn enough to be seated in. So pretty good wear life. I don't think we're too worried about that.
Tom, on the last slide,
This
brush,
one?
that's on the face or the shaft?
That's on the face.
And still have that wear life?
Yes,
It's not a constant.
right. Yep,
Oh, yeah.
good. Good catch. So,
So the seating in really isn't an issue.
right,
It can be just a tiny, tiny contact point of a new brush and it's still okay.
yep.
Because you're not passing, you know, hundreds and hundreds of amps through.
Not hundreds and hundreds,
Yeah.
but the current level is surprising. But,
Is it imperative that that grounding strap be as short as possible?
no,
Because it
No.
wants to take the path of least resistance, so.
yeah, the wire size needs to be adequate for the current encountered, which in some cases will be, in this case, as high as 20 amps.
Well, that's grounded right to the frame of the motor and that.
Right. But that 20 amp is in a spike, and that spike measures about 3 milliseconds every 50 milliseconds. So you've got some time there, you know, cool down time. So you can have the wire slightly undersized, and it won't be a problem. Go ahead.
I apologize for coming in late, Tom, but do you have to have a brush on each end of that shaft?
Next couple slides here. Thanks for reading ahead. You can mount these very easily, and this example is showing what we call a dual lock mount. We're not supposed to use the Velcro name, but that's what it is. So it works pretty quick and easy. I don't have your question on the next slide like I thought I did. And I'm sorry, please repeat your question.
Oh, well, I know you got a current coming through that.
Yeah.
Every current has to have a complete circle, so I'm wondering where the other end of the circle is hooked up.
Well, and that's what I was getting to earlier. The VFD manufacturer will tell you that the building ground, the VFD ground, and the motor ground all have to be one common point, and that brush is then grounded to the motor frame, which is part of that single grounding point. So it does complete the circuit to ground, and it does hold that voltage very low. So
What I'm saying is you're inducing a longitudinal current in the shaft, right?
there is a current in the shaft, and I think part of your question also was if you have to ground the other end of the shaft.
Yep.
Because the non-drive end is usually a smaller shaft and a smaller bearing, that bearing is probably more susceptible to damage than the drive end is.
Okay.
But they're both susceptible. You will still have a voltage on the non-drive end if you apply the brush on the drive end.
Okay.
It will be very small because the shaft will still have some voltage that's developing at that end, but it won't be anywhere near as much. If you want the ultimate in protection, yeah, you'd want to ground both ends. In most cases that we're concerned with, it's probably adequate to ground just the drive end. And also in grounding the drive end, you protect the components that the motor is coupled to, because usually the transmission bearing or something like that may be a bigger bearing with more torque load on it, and it may have a lower voltage point than what the motor bearing does. So you may actually have a transmission bearing fail before the motor bearing does. And so it's most important to be on the drive end first.
Okay.
So, yeah, go ahead.
How much of a concern is this for our motors with varying torque loads and not running 10 years straight?
It's very much a concern. There are examples of electric vehicles with three-phase motors being driven by VFDs.
How would I know? Would it just make noise, or what are we talking
Yeah,
about? 1 year, 15 year?
you'll hear it rumble and make noise. I'm also working with General Electric. General Electric is probably the first company to encounter this phenomenon and to come to us for a solution. And in the recent year, I've been working with GE with the 2.5 megawatt wind generators. And they have a motor for each blade to pitch that blade, And because wind velocities are greater with altitude, they actually pitch that blade differently for the blade that's at top compared to the blades on the bottom. So this is working these motors all the time. These wind pitch motors are DC motors rated at 100 volts DC, and they're the size and mechanical configuration of a warp 9. And there's 3 of them on each one of these wind generators. And they were having, about a year ago, they came to us and said they were having a premature bearing failure, and they pulled the bearings apart, saw the classic fluting. I'm going to pass this around while we're talking. And this is a cutaway of a bearing that shows that fluting caused by the electrical discharge. But those wind generators were failing those motor bearings prematurely, and we ended up making a custom kit for them to insert through the brake housing on the non-drive end of the motor to touch the end of the shaft there and thereby prevent the problem. So,
does everybody understand the base problem this starts with? An AC motor, an AC induction motor particularly, you're inducing a current in the rotor, and that's what you react with the field in the stator. The stator's mounted to the case. The rotor only touches the case through the bearings. You induce a current, you have a voltage. If there's a voltage differential between the shaft or the rotor and the case of the motor, that's easily resolved because it's all metal. It simply goes through the bearings. Unfortunately, it pits the bearings. And what he's doing is grounding with a brush the shaft to take away that voltage differential. And it's particularly a function of, he's calling it a VFD drive, but a PWM, a power switch created sinusoidal waveform. All of ours are.
yeah.
And it's not a function of the motor turning, it's a function of the induced current, and so a voltage differential between your shaft and the case, and the only way through it is the bearings. And so I didn't realize this was a problem, but apparently bearing erosion, it's probably worse of a problem with our continuously varying waveforms than if you just simply had a motor turning. I don't know that's the case, but it could be.
Yeah, and 2 things I'd like to add to that real quick. Thank you for triggering memory here. The wind pitch motors I was talking about with the GE wind generators, those are, excuse me, those are DC motors, driven pulse width modulated off from a DC to DC converter that is a GE proprietary, but it's running at 15 kilohertz and, you know, pretty standard stuff. It's very similar to our DC motors. And
But this also applies to AC induction motors specifically.
it's probably more prevalent in AC, and especially with the latest model VFDs allowing user programmable carrier frequencies. And the higher those carrier frequencies are, the more predominant this phenomenon is. So, sure. Go ahead.
I unfortunately could not mount that on the drive end of my motor because the coupler actually goes into the base of the motor quite a bit. It's recessed. Do you have a efficiency reduction on mounting this in the tail shaft of the motor?
I don't
The drive
know.
end?
Yeah, I don't know.
Is it a noticeable difference or?
It'll be slight. It'll still help tremendously compared to what it was before. So,
If your coupling was up ground, could you grind the coupler on the shaft?
oh, sure. Yep. Go ahead.
So it sounds to me that, you know, part of this is the breakdown of the dielectric grease, right?
Yeah.
Is part of what's causing the pitching of the bearing. Would it not be possible to use a conductive grease?
That is one of the solutions, and I think it was on the list.
Yeah, it was.
It doesn't have a good track record with conductive greases because the conductive particulates that are in the grease to make it conductive are wearing particles also. So
Conductive grease in an electric vehicle is a bad idea. It's just, think about grease, how it gets over everything. And you have a conductive path that you're not even able to see.
yeah.
We were having a conversation earlier today about a specific application where they're interested in this grounding, but they use ceramic bearings.
Yeah.
And so the ceramic bearing, and I've been puzzling over this all afternoon. The voltage still doesn't go away. The bearings would act as an insulator.
Right.
So you still have the voltage difference. Where has the problem moved to? From the $12 bearing to the $120 gear on the end of the shaft.
I was gonna say it goes to the gear,
That's not the solution.
Well, it can be in some cases, and it depends on, you may have to put ceramic bearings throughout. And ceramic bearings are known for being more efficient than steel bearings. They're also known for being 10 times the cost. And my thought is that our brush is much cheaper than the ceramic bearings. John?
A point was made earlier, retrofitting to my car, the only practical place to put the thing would be on the tail shaft.
Yeah.
And from what I understand you're saying, that's going to give me a 90% solution.
It'll work, and it may end up being a 75%, but it'll work.
Is that a lot better than a poke in the eye with a sharp stick?
That's right.
My other question is, doing it on retrofitting to something like the tail shaft, being steel, of course, it's liable to corrode. So it's just the degree to which you've got a problem if you've got the thing, if you like, exposed to the outside air of corrosion of the steel shaft, because unless you've got some part of the kit that's copper or something on the outside, how does that work?
Well, the brush will ride on the shaft and most likely maintain a corrosion-free track right where the brush is, because it's going to deposit its film on the shaft, and that will be corrosion-proof right there. And then as long as your ground connection to the brush is kept corrosion-free, it should be fine.
Is this phenomenon a function of voltage? Have you tried it on like a 10-volt motor versus a 480-volt motor?
I haven't gone that extreme, but we have done quite a bit of testing at different voltages. I've gone as low as 230 volts. That is part of the ongoing test I'm not quite finished with yet. There are many other solutions to this besides the ceramic bearings and some of the other ones we talked about. There are inductors called Cool Blue. It's one of our supposed competitors. Cool Blue is a very well made inductor that goes around your motor leads. They do reduce common mode current, but we have found through testing recently that the shaft voltage is unchanged. So it helps to reduce common mode current and common mode voltage, but it still has a problem with shaft voltage. So you still need a brush. And even Cool Blue on their website, they said that for ultimate protection, you need their inductors and our brush. So just put the brush on. It's much easier and cheaper. There were a couple other points here. It's definitely a problem that is made worse with higher frequencies. So go ahead.
Yeah. You commented earlier that the arcing only takes place every 15-20 seconds?
No, it's I was monitoring. I have to go back to those scope traces. I believe it was a 3 millisecond pulse every 50 milliseconds or something like that. It's occasional, but occasional at that short time interval is still quite often.
And was that like some multiple of the switching frequency or the switching period?
Yeah, definitely. And it's a function. Very good question. Thank you. You led me into some other stuff. It's a function of carrier frequency, RPM, the number of balls in the bearing, because the long life bearings are usually 11 ball, whereas the standard bearings are usually 8 ball. All of that plays into that. And the temperature, of course, is going to affect the grease, and there's so many variables here, it's really hard to predict. But I can tell you that the higher speed the motor is operated at will help to shorten the life of that bearing. Now, whether that's due to the higher speed causes higher wear on the bearing anyways, or the combination thereof, but the phenomenon and the bearing problem is made worse at higher operating speeds. Yeah.
I saw a thing on the internet, they come out with a new bearing design, which is different from standard bearings. I don't have it with me here to show it, but have you heard anything about that, about the new bearing design?
No, I
It
don't.
just came out like in the last 3 months, they're expecting it, it's not a circular shaft for the bearing to ride in, there's more of an oblong or something.
Sorry, I don't know anything about that. Lee?
Could you give us a little more time to look at your first 2 slides? Because I didn't get enough time to really study this.
Okay. Not that one.
You're on.
Uh-oh. There we go.
You want to give him a hand, Nick?
This one?
The first 2, no, I mean the first 2 that had the need for grounding
Yeah.
and the susceptible motors slides. Those, I
gotta
just
get
wanted
back
to
up.
have a little more time to
Sure.
check. Thank you.
And there was some other question. Yeah, go ahead.
Do you have a brush carrier for this in a cylindrical housing that can press through a radial bore?
Yes. Yes, we do. In fact, that's almost exactly what we came up with for a solution for GE on the wind pitch motors. Yeah.
Okay, very good.
Do you do kits for the AC50 and what's the damage?
You know, we don't have motor-specific kits, but we do have the kit that was pictured as being our most common option, and also the smaller one that I showed that Baldor's putting inside their motors, in their premium motors. So yeah, we have some.
So these silver graphite brushes are essentially almost free, right?
They are 91% silver.
And the prices are going up.
Go ahead.
Really?
Oh, darling. Nice piece of jewelry.
How critical is the mounting distance from the brush holders to the shaft?
That's a good point. It should be 100 thousandths from the shaft.
Wow.
So, go ahead.
Do we need to polish our shaft to a specific finish before this is installed?
I won't specify the finish, but any cross lines or cross hatching or deep scratches will shear the brush with every revolution and result in much shorter life. So you want to make certain the shaft is smooth.
But you sell more brushes that way.
Yeah, well, go ahead.
In the old days, we polished down the commutator with emery stuff. I don't know if that's appropriate.
Yeah, garnet paper, emery, whatever. Yeah, just make it as smooth as possible so that you don't wear the brush up crazy, you know.
Okay, so the problem is actually more pronounced in an AC motor than a DC motor.
I wouldn't say that. I would say it's pretty much dependent on the carrier frequency, more so than AC or DC, but it exists in both cases. And the GE motors that they're having problems with are DC motors. They're very similar to a warp 9. They're wound a little bit differently, but they're DC motors. So we got brushes in the motor itself, and we got brushes on the shaft too.
The brushes on the inside don't help at all. It's just a waste of it.
Right.
What's the operating voltage on that wind turbine motor?
100 volts, but it's coming from 200 or 180, so it's almost a 50%
Gotcha.
duty cycle,
Okay.
and that plays into it also. So yeah. Okay,
Thank you.
you're welcome. Go ahead.
So you're saying that the Velcro maintains 1,000th of an inch difference?
The Velcro would be on the side, and then the brush, the face of the brush holder should be 100 thousandths from the shaft, so that the brush is only extending from the holder
Right.
100 thousandths.
But Velcro is gonna maintain that?
Oh, yeah. Yeah, the dual lock that we use is a 3M product, and I don't know if that's the reason why I have to call it dual lock instead of Velcro, but it's so strong that I have to jam a screwdriver into it and pry multiple times to get it off, so.
I actually have a reel of this up in the battery lab, but you can take a look at our Jev Cube in the yellow thing. It's a white plastic,
Yeah.
and it's not like a white nylon polyethylene. It's not what you think of as Velcro with felt or something. It's and it's strong.
Yeah. Yeah, both halves are the same.
Both halves are exactly identical.
Yeah.
In fact, it just comes on a reel,
Yeah.
and you peel the paper back, and the gummy side's pretty strong too.
Stick to each other.
Yeah.
And you put two of these things together.
Yeah.
It's technically you can get them apart, but it's break back a lunch.
I have to break half of it to get it apart. So, yeah.
Most of our motors don't have an aux shaft, and most of our drive shafts are kind of buried in an adapter or a transmission or something like that.
Yeah.
How do you deal with that?
Yeah, it may take some foresight when putting that together, make an access hole in the adapter plate or something so that we can get something in there. So it may be easier said than done, but yes.
What's your least expensive solution here?
I don't have prices, but I think that the mount that I showed you that is going into the Baldor motors, I think that's going to be the least expensive one. And I don't have prices on those.
So we can give you our email address and we'll get it.
You get samples to try.
Yeah, samples.
Tom, can you go to the next slide right after that one, please?
So,
So you define the problem, you describe the solution, and we can't have it.
well, we can have it. We can have it. The best price, which I don't have prices, but the best price is obtained if we order by a group and get that volume up there, which will help quite a bit.
That's how I wound up with that $4,000 worth of brushes. Same story. I got bid on this once before.
It seemed to me that with this problem you're describing, that best be solved by the motor manufacturers themselves and building that into the design of the motor. Are any of these motor manufacturers expressing any concern or desire to switch to that?
Right. Baldor already has. Leeson, which is now called Regal Beloit, they're starting to do it now also. GE, of course, in their own applications, because it's their own wind tower, you know, there are some other interests. So it is beginning, but we've been supplying this to GE for 24 years.
But the engine manufacturers
You think it's
are
gonna
aware
catch
of
on?
the problem. The manufacturers are aware of the problem.
Oh, very much so.
Yeah, I was going to ask if you're aware of the Siemens or UQM motors that are starting to gain interested in having computer products.
Not that I'm aware of.
The industrial generators do.
Yeah.
Yeah. I shared with Tom some field experience.
Yeah.
15 years ago, Energy Mike on wind turbines, you know, they're 750 kilowatt machines, 960 volts, what is it, 1380 RPM type number. They were trying to solve this by taking a brass, what looked like a toothbrush, rub on the shaft. I saw it after a year. They had a furry shaft and a naked stick. They had spot welded itself to it. So then they tried what looked like a battery grounding strap.
Yep.
And within a couple of weeks, that just tore itself to pieces, arcing to the shaft.
And
they were showing me literature from back in 1920 with AC generators. That this is a common problem. They were describing the eddy current size. If the shaft is facing you, it's actually running around in that axis.
Yeah. We discovered many years ago, even before this phenomenon, that you can't put too much metal in a brush that's running at higher voltages, and it will micro weld and cause a problem. So we had one of the electric vehicle racers, I won't mention any names, but he insisted that he had to have metal brushes, and he was running at 200 some volts or something like that. And
John Mitchell.
no, it was not John. And he insisted, and I told him, no, we're not going to do it. It's ridiculous. You're gonna weld the brushes to the comm, and you're gonna spin the brush holder mounting ring right out of the motor, and everything's gonna twist around, and it doesn't work. We won't do it. So metal, we do make metal grade brushes, and they're applicable to motors below 48 volts only. And then they won't weld. But even at 48, you're on the fringe with that, so.
How about this phenomena for bronze bushings? Like, a lot of big things have bronze, surprisingly, have a bronze bushing bearing.
You know, I think it's still gonna arc through there, through that oil film or grease film, whatever it may be, and.
But there's so much more surface area.
And that'll help, but I think it'll still happen. It'll just take longer.
Have you seen a bearing failure in the HPEDS AC series?
I have not, but I was teasing Brian Seymour about that several years ago, that he was going to need a brush anyways. And he said he had 0 failures. Well, that's fortunate.
Yeah.
And we certainly don't wish any failures on him, but his motors are going to need that also. I mean, it's just a point of the carrier frequency, and it's going to happen no matter whose bearing it is. And he may be using some really good quality bearings. It's still going to happen. So. Oh yeah.
Probably not at the new motors at the factory.
Well, they're going to sell
Yeah,
more
0
motors
failures
and parts.
while
That's
he's
why
working.
some of these motor companies aren't doing anything about it.
And it's an added expense for them when you're trying to save expenses. NetGain is also interested in putting them inside. So.
You're still around?
Yeah, I guess.
So Tom, whether or not it's an AC or DC motor, and you're talking about the 3 points of contact. So on EV, where would you would just settle with grounding the motor to the frame of the car, or?
You need to ground the motor shaft with the brush,
But-
and then where you hook the wire from the brush that's on the motor shaft, it should go to the motor frame someplace clean and good electrical connection, so that you want to create a parallel path to the bearing, and our brush will be magnitudes of lower resistance than what the bearing will be. So the majority of the current will always go through the brush.
So then would you go to the car frame?
From the motor frame to the car frame, it is not a bad idea. I can't answer that exactly because I don't know how it's set up in your car or all cars. So, but yeah, it'd be wise to ground it to the
It
car frame
doesn't
too.
really matter you don't want to current through the bearing, and if you have both sides of the bearing grounded together,
Nice choice.
Yeah.
it will go through the bearing.
I think I'd probably go to the concept.